Okay, so far we've added hydrogen halogen, and we've added water across our double bond. Now we're going to add hydrogen. So this is catalytic hydrogenation. We're going to do this with hydrogen gas plus platinum. And it's just going to take out the double bond because we've added a hydrogen here and we added a hydrogen here. The nice thing is we don't have to worry about whether it's Markovnikov or anti-Markovnikov because we're adding two identical atoms. We do still have to worry about some stereospecificity. If two chiral centers are made, both hydrogens will be up. Well, let's see, both protons will be up, or both will be down. So here's our example. We're going to add hydrogens to this position and to this position. And the two stereoisomers that will be made will be putting both of these on wedges. That means that our hydrogens were both on dashes. Sorry about that, not great. Or we could have our groups on dashes, which means that our protons that we added were both on wedges. So these are the two enantiomers that we observe. We do not observe this. With that one on a wedge and this one on a dash, we do not see, and we do not see this either. The bottom one here is on a wedge and the top one's on a dash. These are not visualized. The reason for this is that the catalyst here is platinum. It's a solid surface, and the hydrogens both attack from the same side. They're both going to attack the same face. And so you'll get this syn addition, just like we did, just like we saw before. Do watch out for meso compounds, because with meso compounds such as this one, you'll get this and this. They are the same. So you did not make enantiomers in this case. So let's see if we can predict the products that we might get. So we're going to add a proton to here, and we'll be adding a proton to here. We will not be making a chiral center at either of those places. So our result will be just the same compound, but without the double bond. So here we're adding a proton to here and a proton to here. There's already one proton at the second position, and so that's not chiral, and this is not chiral because the ring is the same in both directions. So we haven't made a chiral compound, so we get this. We're going to add our proton to here and to here, and we'll get and again, we don't have any chirality to worry with. There are some homogeneous catalysts. Heterogeneous catalysts are things like platinum and palladium and nickel. They don't dissolve. So if you remember, it was a long time ago, but 170, we talked about heterogeneous. That means having two layers. Homogeneous catalysts are things that dissolve. And one of the common ones is this Wilkinson's catalyst. And they're going to result in syn addition in the same way that our homogeneous catalyst did. So if we use a Wilkinson's catalyst, we'll get something very similar that if we used palladium. And the enantiomer. I'm just not going to draw it.